Welcome back to HoloBit. In the last video, we built the protocol's core mechanism and completed the cold start. Now we'll continue building a complete micro-protocol ecosystem around it. This video focuses on 3 upgrades. First, introduce Uniswap V2 as a secondary market for token trading. Second, complete user behaviors. Early investors add initial liquidity. Traders buy and sell on the market. Third, introduce Arbitrageurs, who discover and eliminate price spreads between 2 markets. Our ultimate goal? Observe whether price convergence emerges spontaneously. 2 markets, 1 balancing force. Let's see what happens. To track this, we need some global variables. Let's add them first. First, market-related parameter. Create marketTrend. Set it to bull. Bull market means more buying. Bear market means more selling. Second, agent participation controls. Create trader enabled and arb enabled. Set both to false. These let you toggle participants on and off. Third, price observation. Create primaryPrice and secondaryPrice. Set primaryPrice to 1, secondaryPrice to 0. These are the key indicators we'll watch. Also add controllers for these 3 parameters, so it's easy to tweak them before you hit run. Now let's introduce Uniswap. Here we'll try something efficient using a published block file from the marketplace. No need to build from scratch. Go to the marketplace, find the block file named Uniswap V2, and open it. Click the Use button on the top right. You can also save it to your workspace library for future use. Back on the canvas, you'll find it in the Block tab under your Marketplace blocks. Just drag this block onto your canvas. Uniswap appears. All the logic is built in. Now let's adapt it to our model. The changes focus on property variables. Set the agent type to population with 1 individual. Then configure the main properties. First, pair name. Set it as a 2-item list, X and USDC. Second, liq pool. Set the entries for X, USDC, and LP token all to 0. Third, fee rate. Keep it as the default. Fourth, set total supply to 0. Fifth, price. Create 2 entries, X and USDC, and set both to 0. Sixth, set K to 0. Finally, burned LP tokens. Add the key and set it to 0. On the agent cover, expose the main properties and processes with a clear layout. Give it a logo like a unicorn and set the color to pink. Now let's look at behaviors. Block files don't allow adding or deleting components, but you can change existing settings, especially formulas. For Uniswap, we need to update secondaryPrice whenever price updates. Right-click on price, select Find References. You'll see every component that touches it listed in the console. First, locate Create Pool. In the formula box, add a single update for secondaryPrice. Next, find the 2 transfer tokens components. Add the same update to both. After each transfer, refresh secondaryPrice with the X's price. That handles secondaryPrice. Now let's do the same for primaryPrice on X protocol's side. Find references to current X price. In Mint X and Redeem USDC, add 1 update. Whenever current X price is computed, copy it into primaryPrice. Now our global variables will automatically track the real-time prices of both markets. Return to root canvas. Create a chart for primaryPrice and add secondaryPrice to its y-axis. Next, we'll let team and investors add initial liquidity for a test run. They already minted tokens for initial liquidity ratio. We just need a process to send them into the pool. Go into Team and Investors and create a new process called Add Initial Liq. Inside, keep it simple. 1 call, then end. Set the start event to timer. Start at tick 3, run for 1 tick, and turn active on. Now configure the call. Owner is Uniswap. ID is 1. Behavior is add liquidity. Pass the inputs. Token A is X. Token B is USDC. For amount A and amount B, enter the expressions shown on screen, and make sure amount B is amount A adjusted by primary price, so Uniswap's initial price matches the protocol. Finally, create a wallet reference and connect it to the user wallet port. Done. Let's run the model. You should see, the pool now holds 10 million X, and LP tokens appear in the wallet. On the chart, primary price reaches about 13.7 at tick 2, and secondary price matches at tick 3. Everything checks out. Great, Uniswap now has liquidity. Now traders come to trade. Traders already hold X tokens from the public sale, but they won't all act the same. So we'll control buy versus sell with different probabilities depending on the market. First, change population size to 30. More traders than early investors. That's realistic. Second, create 4 variables: bull buy prob, mixed buy prob, bear buy prob, and trade size scale. For each one, set the value, then set belong to collective. Set the initial values to 0.6, 0.5, 0.4, and 300,000. With properties complete, let's set up behaviors. Create a process named goSwap. The logic has 3 checks, then 2 actions. Check if trading is enabled, check market condition, and decide buy or sell. Then call the swap. Build the process like this. Start with a gateway that ends the process when trader enabled is off. If it's on, go to a second gateway that branches by market trend: bull, mixed, or bear. On each branch, add one more gateway that randomly chooses buy or sell. Then route all buy paths into one buy call and all sell paths into one sell call. Both calls end the process. Now, configure the components. Set start event to timer, starting from tick 4, repeating every tick. And turn active on. For the first gateway, set it to conditional and add a simple condition. If trader enabled is true, continue, otherwise end. The second gateway is also conditional. Add 3 conditions and route each path to its corresponding branch: bull, mixed, bear. Then for these 3 buy or sell gateways, set the type to probability. On the bull branch, buy probability is bull buy prob. Sell is the remaining probability, 1 minus bull buy prob. Mixed and bear follow the same pattern. Just swap in mixed buy prob and bear buy prob. For the buy call, set owner to Uniswap V2, ID to 1, behavior to swap in. Amount in is trade size scale. Token A is USDC. Token B is X. Connect the trader's wallet. For the sell call, also use swap in. For the amount, use the smaller of the trader's X balance and trade size scale divided by secondary price, so traders never try to sell more than they have. Token A is X, token B is USDC. Connect the trader's wallet. Now let's test. Back on the root canvas, turn trader enabled on. Click step 4 times. You'll see each trader starts with the same X from the sale. After more steps, balances begin to diverge, because each trader is making different random choices. With traders active, prices become dynamic. A spread starts to appear between the primary and secondary prices. And once that spread is big enough, Arbitrageurs will step in. Now let's introduce the last player type, Arbitrageurs. Let's create a new agent and define what it is. First, set the agent type to population, with the initial number of 20. Second, add 1 container named RB wallet and 4 variables that belong to collective. For RB wallet, set the key to ERC20, set X to non-negative, and allow USDC to be negative. For ARB size scale, set initial value to 10,000 and set belong to as collective. This is the trade size per arbitrage. Too large means more slippage. Set min profit threshold to 0.05, also collective. This defines how large a spread is worth acting on. Leave average ARB profit at its default for now, and keep it collective. This tracks arbitrage income. Set ARB logs to list with no initial value, and keep it collective. This records trading logs like each arbitrage's time and profit. Great. Agent properties are complete. Next, let's define what arbitrageurs can do. Create a process named goArbitrage. The structure is similar to goSwap. 2 checks, then actions. Build the logic like this. After start, add a gateway that ends at the process when ARB enabled is off. If it's on, go to a second gateway that checks whether the spread is big enough. From there, branch into 3 paths. If Uniswap is expensive, take forward arbitrage. Add 2 calls. Buy low on X protocol, then sell high on Uniswap. If Uniswap is cheap, take reverse arbitrage. Add 2 calls. Buy low on Uniswap, then sell high on X protocol. Otherwise end. No arbitrage. Finally, to connect both action paths into a statistics component and end the process. Now configure these components one by one. First, set the start to timer. Start at tick 4, run every tick and turn active on. Second, for the first gateway, set type to conditional. Add a simple condition. Continue only when ARB enabled is true. For the second gateway, set it to conditional as well. Add 2 conditions that compare the 2 prices as a ratio. If Uniswap is higher than the protocol by at least the threshold, go forward. If Uniswap is lower by at least the threshold, go reverse. Otherwise, go to end. Next, configure the arbitrage actions. On the forward branch, first call mint X on X protocol to buy X at the protocol price. For the amount out, use the expression sized to match ARB size scale. Input token is USDC, output token is X. Connect ARB wallet to the user wallet port. Then for the second call, point it to Uniswap V2 and pick ID 1. Then select Swap In to sell X back to USDC. Set amount in to the wallet's X balance. Token A is X, token B is USDC. Connect ARB wallet to the trader wallet port. On the reverse branch, for the first call, set owner to Uniswap V2 and choose ID 1. Then select Swap In to buy X with USDC. Pass the inputs. Amount in is ARB size scale. Token A is USDC, token B is X. Connect ARB wallet to the trader wallet port. Then call redeem USDC on X protocol to sell X back to the protocol for USDC. Set amount in to the wallet's X balance. Input token is X, output token is USDC. Connect ARB wallet to the user wallet port. Finally, in statistics, set targets to arbitrageurs.all. For indicator, use the USDC balance in ARB wallet. Name it profit and set method to average. In compute before action, append a log row with the current tick and USDC balance. In compute after action, store the rounded profit into average ARB profit. Great, arbitrageurs are ready. Now locate the ARB enabled and turn it on. Run the model. First, on the price chart, you will see secondary price fluctuates around primary price. This shows the market balancer's effect. Second, find average ARB profit and auto chart. You'll see the profit trend move over time. Then, let's create a new chart to track where X ends up. Drag a chart to the dashboard. Name it X distribution and set type to Pi. Draw by latest data. split sectors by field name. For the sector values, add every container that holds X. X protocol's issuance pool for unminted portion, Uniswap V2's liq pool for circulating portion, and the wallets of each user type. You'll notice Arbitrageurs hold almost no X. They buy and sell quickly, ending mostly in USDC. You can remove their X slice from the pie. You may also notice the total doesn't equal max supply right now. That's because the current statistics only count one individual for investors and traders, not the whole population. There are a few ways to fix this, including adding a dedicated tracking process inside each user agent. Here we'll use a root canvas process, because it gives us a clear execution order and more accurate statistics. It also removes the need to juggle timers. We run things in order: pre-sale, then public sale, then liquidity, and finally market dynamics and tracking. Let's implement that next. First, we'll stop user agents from running automatically. Go into Team and Investors. For pre-mint X, turn Active off. For Add Initialize, change Start from Timer to Normal and turn Active off. That way, these processes only run when called. Then repeat the same cleanup for traders and arbitrageurs. For each one, find the active process, change Start to Normal, and turn Active off. Also for goArbitrage, we'll remove statistics, since profit is tracked in the main process. Before you delete it, keep the log update. Move the append tick and USDC balance line to the end event's compute on trigger. Now return to the root canvas and build the main process. Step 1. 3 one-time calls. Add 3 call components in sequence: pre-sale, public sale, and add liquidity. For the first call, set owner to team and investors, choose all, and select pre-mint X. For the second call, set owner to traders, choose all, and select buy from public sale. For the third call, set owner to team and investors, choose all, and select add initial lick. That completes the one-time setup. Step 2. A subprocess for market dynamics and tracking. Add a subprocess and expand it. Set its start to timer. Start at tick 1, run every tick. Then add 2 calls in order. For the first call, owner is traders, choose all, and run goSwap. For the second call, owner is Arbitrageurs, choose all, and run goArbitrage. Now, add 3 statistics components to track holdings and profit. The first one tracks team and investors' X holdings. Set targets to team and investors.all. Set indicator to the team and investors' wallet's X balance. Name it X holdings and set method to sum. In compute after action, add 1 line to store the result. The second one tracks traders' X holdings. Targets are traders.all. Set indicator to the trader's wallet X balance. Name it X holdings. Method sum. In compute after action, save the result. The third one tracks Arbitrageurs' average profit. Targets are arbitrageurs.all. Set indicator to the Arbitrageurs' wallet, USDC balance. Name it average profit. Method average. In compute after action, enter the formula to copy the result into goArb profit. Next, let's keep everything in sync each tick. Start by updating xprotocol.totalXsupply. Enter this formula shown on screen. Then update primaryPrice and secondaryPrice. For the X distribution pie chart, switch the data sources. Use X holdings for team and investors, and trader X holdings for traders. That's it. The main process is complete. Now run the model again. On the chart, the total now roughly matches max supply. Any small gaps come from rounding, not bugs. Finally, tidy up the model and dashboard so it's clean and easy to follow. Now try different scenarios. Set market trend to bear and run again. Notice that the market price still fluctuates around the primary price, but the overall trend moves downward. You can also try different curve shapes to verify other functions behave normally. And for easier testing, besides the global parameters, you can also turn key parameters inside agents into controllers, like trade size scale, RB size scale, and min profit threshold. So they're easy to tweak before each run, especially when sharing the model. Great. Our bonding curve model is complete. We've shown the mechanism, why the secondary market price fluctuates around the protocol price. With tools like HoloBit, you can design and evaluate protocol mechanisms, explore alternatives, and communicate value faster to build community consensus. That's our bonding curve modeling introduction. Thanks for watching. In the next video, we'll turn this into an experiment lab